Alright, our second set of notes for this unit will be on page 41, and the title will be Area of Regular Polygons. So let's go ahead and turn to page 41. Remember to add your page number and your title. And I would like you to sketch a regular polygon. I have chosen a pentagon, however you could choose a hexagon or an octagon, whatever is easiest for you to draw. The first thing that we're going to do, as we decided in class, it's easiest to, from the center of the figure, draw lines to each vertex to divide the polygon into triangles. So I'm going to do that on our example. Find the center and sketch in lines to each vertex. So I have divided my pentagon into 5 congruent triangles. Next, we're going to find the area of one of those triangles, and you get to choose which way you want to write the formula for area. So you could write it as base times height divided by 2, or if you prefer, you could write it as 1/2 times base times height, or if you prefer, you could write it as base times height divided by 2, like that. You choose which of those area formulas is easiest for you and write in the one you like. After we found the area of one triangle, we will multiply by the number of sides. So I have drawn an example, and this time I would like you to draw a pentagon as well. So in my pentagon, I know that the sides are 8, and since it's a regular polygon, draw yourself a thought bubble, that regular polygons, all sides are congruent. So even though only this one side is labeled as 8, because it's a regular polygon, we know that all 5 sides have a length of 8. And then in this example, we are given that the height of one triangle, which is also called the apothem. So let's go ahead and add that vocabulary word that, I'm trying to think where I want to write it. Okay. From the center perpendicular to one side, we call that the apothem. So both of those are pretty important pieces of information, so I'm going to go ahead and outline my thought bubbles so I can find that information quickly when I need it. And if I don't remember, it's a good way to say, aha, that was important information. I need to go back and remember that. So to find the area of this one triangle, I'm going to choose our third representation of area. Since all sides are congruent, I know that the base of this one triangle is also 8. So the area equals 8 times the height, which is given to us as 5.5. Oops, that's a 0.5. Divided by 2. And then I have to multiply by the number of sides. Since this is a pentagon, there are 5 sides, so I'm going to multiply by 5. And when I multiply all of that out, I get that the area is 110. And since there are no units listed here, I know that that is just units squared as my label on that example. So let's do one more example. So this is going to be example 2. And this time I'm going to draw a regular hexagon. And the information that we are given this time is that a side is 12. So I'll start just the way I did before and go ahead and draw in a triangle from the center. And I'm going to sketch in the height. We're not given the height this time. All we're given is that one side is 12. So we are going to have to find the height. And remember that when we talked in class, when it's a hexagon, we know that this triangle is an equilateral triangle that has a side length the same as our base, so that side is 12. And our apothem is going to divide this side in half, so we know that this side length is 6. So let's come over here on the side and make a note that we need to find the height. And to do that, we're going to use a squared plus b squared equals c squared. 12 is our longest side, our hypotenuse, so that has to be our c. And it doesn't matter, the 6 can either be the a squared or the b squared, and I'm going to choose to put it in as the b squared. So let's go ahead and solve this out. A squared plus 36 equals 144. Subtract 36 from both sides, so a squared is going to equal 108. Take the square root of both sides, and a will equal 6 square root 3. So now we have found that our height of our triangle is 6 square root 3. Ooh, that covered that right up. Can't see that. I'll rewrite it in. And I'll circle it. Okay. So now we're ready to go ahead and find our area. So our area is going to equal our base, and remember that the base of our whole triangle is 12 times the height that we found, which was 6 square root 3. This time I'm going to write it as divided by 2 as a fraction. And then because this is a hexagon, we will have 6 triangles, so I have to multiply by 6. And when we calculate that, our calculator will tell us that that gives us 216 times the square root of 3. So that is our final area for that example. You can use this method to find the area of any regular polygon, as long as you remember that sometimes you have to find your height, and sometimes you're given that information. And if you have to find your height, remember that half of your base will give you the side length of a or b in a squared plus b squared equals c squared.